The heating system being discussed is likely an electric radiant ceiling heating system. It works by embedding heating wires, usually below the drywall, in the ceiling. When electricity flows through these wires, they get hot and radiate warmth into the room. The method of finding a broken wire involves using a metal putty knife or something similar that conducts electricity. This is connected to a wire to create an electrical arc between the hot wire and the broken wire. The location where the arc appears gives you a good idea of where the break is. If you are considering this method, firstly turn off the power to the heating system at the breaker panel. Secondly, you need to find the hot wire that feeds the broken section. A voltmeter can help with this, or you can trace the wires back from the electrical panel. Thirdly, attach a wire to a metal putty knife or another conductive object. Fourthly, carefully run the object along the ceiling following the path of the hot wire. Make sure you are holding the object in a way that you are insulated from the ceiling itself. Fifthly, watch for an arc. As the object gets close to the broken wire, an electrical arc should form. The place where you see the arc is approximately where the break is located. Sixthly, mark that spot on the ceiling. It's very important to remember that this technique should only be done by qualified electrical professionals. Working with live electrical wires is dangerous if you don't know what you're doing. Always follow electrical safety rules, including wearing gloves and eye protection. There are alternative methods that can be used. Firstly, thermal imaging. A thermal imaging camera can help you find areas that are hotter than others, which could point to where a broken wire is. Secondly, resistance measurements. Use a multimeter to measure the resistance along the wire. A sudden change in resistance can indicate a break. Thirdly, wiring diagrams and cable tracing. If you have wiring diagrams, use them. If not, a cable tracer can help you follow the path of the wires and find any breaks. Here are some additional details about electric radiant ceiling heat. Electric radiant ceiling heat provides a consistent and comfortable heat. It consists of electric resistance cables that are embedded in the ceiling. This warms the room evenly through thermal radiation. Unlike forced air systems that heat the air, radiant heat directly warms objects and people in the room. This reduces drafts and dust circulation and provides a more efficient and comfortable heating experience. Here is a more in-depth discussion about the technique for locating the break in the wire. The arcing method relies on the principle that electricity will take the path of least resistance. When a wire is broken, it creates a gap in the circuit. By introducing a conductive object connected to a voltage source, the electricity will jump across the gap, creating a visible arc. The intensity and location of the arc can help pinpoint the break. When preparing the conductive object, ensure that the wire is securely attached and properly insulated. This prevents accidental shocks and ensures a controlled arc. When running the object along the ceiling, maintain a consistent distance to avoid creating unnecessary arcs. Move slowly and deliberately, paying close attention to any changes in the sound or appearance of the arc. Different types of breaks will present differently when arcing. A clean break will produce a small, localized arc, while a more damaged wire may create a larger, more diffuse arc. Here's a more in-depth discussion about safety precautions. Always energize the circuit before attempting any repairs or troubleshooting. Verify that the power is off using a reliable voltage tester. Wear appropriate personal protective equipment, including insulated gloves, safety glasses, and a flame-resistant jacket. Avoid working in damp or wet conditions, as this increases the risk of electric shock. Have a second person present to assist in case of an emergency. Keep a fire extinguisher nearby in case of accidental ignition. Never touch the conductive object or the wires while the circuit is energized. Be aware of the potential for arc flash, which can cause severe burns. Maintain a safe distance from the arcing point and avoid looking directly at the arc. Be cautious of flammable materials in the vicinity of the work area. Cover or remove any items that could easily ignite. Here's a more in-depth look at thermal imaging. Thermal imaging cameras detect infrared radiation, which is emitted by all objects. The amount of radiation emitted is proportional to the object's temperature. By measuring the infrared radiation, a thermal imaging camera can create a visual representation of the temperature distribution across the surface. In the context of electric radiant sealing heat, a broken wire will create a localized hotspot due to the increased resistance at the break. This hotspot will be visible as a bright area on the thermal image. When using a thermal imaging camera, scan the sealing in a systematic manner, overlapping each pass to ensure complete coverage. Adjust the camera settings to optimize the image quality and sensitivity. Look for areas of abnormally high temperature, particularly along the path of the heating wires. Be aware that other factors can influence the temperature distribution on the sealing, such as sunlight, drafts, and insulation. Take these factors into account when interpreting the thermal images. It is also important to note that thermal imaging may not be effective in all situations. For example, if the break is located deep within the sealing, the temperature difference may not be significant enough to be detected. Here's a more in-depth look at resistance measurements. Resistance is a measure of how much a material opposes the flow of electric current. A broken wire will have a very high resistance because the current cannot flow through the break. By measuring the resistance of the heating wires, you can identify sections that have a break. When using a multimeter to measure resistance, disconnect the heating wires from the power supply. Set the multimeter to the ohms setting and connect the probes to the ends of the wire section you want to test. A normal heating wire should have a relatively low resistance, typically in the range of a few ohms to a few hundred ohms. A broken wire will have a resistance that is much higher, often infinite or out of range. When interpreting resistance measurements, consider the length and gauge of the wire. Longer and thinner wires will have higher resistance than shorter and thicker wires. Refer to the manufacturer's specifications for the expected resistance value of the heating wires. Be aware that resistance measurements may not be accurate if there are other conductive materials in contact with the wire. For example, if the wire is touching a metal frame, the resistance measurement will be lower than expected. The wiring diagrams are very important. Wiring diagrams provide a detailed representation of the electrical circuits in the heating system. They show the location of the heating wires, the connections to the power supply, and any control devices. By referencing the wiring diagrams, you can trace the path of the wires and identify potential locations for breaks. Wiring diagrams may also provide information about the expected resistance values of the heating wires. This information can be used to verify the accuracy of resistance measurements. If wiring diagrams are not available, you may be able to create your own by carefully tracing the wires and documenting the connections. A cable tracer, also known as a wire tracer or a tone generator and probe, is a tool used to identify and trace wires within a building or electrical system. It consists of two main components. Firstly, a tone generator, which sends an electrical signal down the wire, and secondly, a probe, which detects the signal and allows you to follow the wire's path. To use a cable tracer, connect the tone generator to one end of the wire you want to trace. Then, use the probe to listen for the signal along the wire's path. The probe will emit a tone that gets louder as you get closer to the wire. By following the tone, you can trace the wire through walls, ceilings, and other obstructions. Cable tracers are particularly useful for identifying wires in complex electrical systems where the wiring is not clearly labeled. They can also be used to locate breaks or shorts in wires. When using a cable tracer, be sure to follow the manufacturer's instructions carefully. Avoid applying excessive voltage to the wires, as this could damage the equipment. Be aware of the potential for interference from other electrical devices. Here is some important code information. Local and national electrical codes, such as the National Electrical Code, or NEC, provide guidelines and regulations for the safe installation and operation of electrical systems. These codes cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. When working on electric radiant sealing heat, it is important to comply with all applicable codes. This will ensure that the system is installed and operated safely and that it meets the required standards. Some specific code requirements that may apply to electric radiant ceiling heat include Article 424.90 through 424.99 of the NEC, which covers fixed electric space heating equipment, and Article 300.11, which covers securing and supporting wiring. Article 424.90 discusses the general requirements, while Articles 424.91 through 424.99 delve into installation in different locations, like ceilings and floors. It is also important to check with your local building department to determine if there are any additional requirements or permits that are needed. It is important to understand some electrical theory. Electricity flows through a closed loop, or circuit, from a power source through a load and back to the power source. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electric charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electric current. It is measured in ohms. Ohm's law states that the voltage across a resistor is equal to the current through the resistor times the resistance of the resistor. This is expressed as volts equals amps times ohms. Understanding these basic concepts is essential for troubleshooting and repairing electrical systems. Electric radiant ceiling heat relies on the principle of resistance heating. The heating wires in the ceiling have a specific resistance value. When voltage is applied to the wires, current flows through them, generating heat due to the resistance. The amount of heat generated is proportional to the square of the current and the resistance of the wire. In other words, heat equals amp squared times resistance. This means that increasing the current or the resistance will increase the amount of heat generated. The heating wires are designed to operate at a specific voltage and current level. If the voltage is too high, the wires will overheat and could potentially cause a fire. If the current is too low, the wires will not generate enough heat to effectively heat the room. Here's a more detailed procedure for repairing a broken wire. Once you have located the break in the wire, the next step is to repair it. The repair procedure will depend on the type of wire and the location of the break. In some cases, it may be possible to simply splice the broken ends of the wire together using a wire connector. In other cases, it may be necessary to replace a section of the wire. Before attempting any repairs, be sure to de-energize the circuit and verify that the power is off. Use appropriate wire connectors that are rated for the voltage and current of the circuit. Ensure that the wire connectors are properly installed and tightened. If replacing a section of wire, use wire that is the same gauge and type as the original wire. After completing the repair, inspect the wiring carefully to ensure that there are no loose connections or exposed wires. Use a multimeter to verify that the resistance of the repaired section is within the expected range. Finally, re-energize the circuit and test the heating system to ensure that it is working properly. The tools needed will include, firstly, a multimeter for measuring voltage, current, and resistance. Secondly, wire strippers and crimpers for preparing and connecting wires. Thirdly, wire connectors for splicing wires together. Fourthly, electrical tape for insulating wires. Fifthly, safety glasses and gloves for personal protection. Sixthly, a voltage tester for verifying that the power is off. Seventhly, a thermal imaging camera for locating hot spots. Eighthly, a cable tracer for tracing wires. When selecting tools, choose high-quality tools that are designed for electrical work. Ensure that the tools are properly insulated and rated for the voltage and current of the circuit. Inspect the tools regularly for damage and replace them if necessary. Store the tools in a dry and safe place when not in use. Regular maintenance is very important. Regular maintenance can help prevent problems with electric radiant ceiling heat. Some simple maintenance tasks that can be performed include visually inspecting the ceiling for any signs of damage such as cracks or discoloration, checking the thermostat to ensure that it is working properly, cleaning the heating wires with a soft cloth to remove any dust or debris, inspecting the wiring connections for any loose or corroded connections. If you notice any problems, such as uneven heating or a burning smell, contact a qualified electrician to inspect and repair the system. It is also important to have the system inspected periodically by a qualified electrician to ensure that it is operating safely and efficiently. The frequency of inspections will depend on the age and condition of the system. Here is more on troubleshooting. If the electric radiant ceiling heat is not working properly, there are several troubleshooting steps that can be taken. Firstly, check the breaker to make sure that it is not tripped. Secondly, check the thermostat to make sure that it is set to the correct temperature. Thirdly, check the wiring connections to make sure that they are tight and secure. Fourthly, use a multimeter to measure the voltage and current at the heating wires. Fifthly, use a thermal imaging camera to look for hot spots. If you are unable to identify the problem, contact a qualified electrician to diagnose and repair the system. When troubleshooting electrical systems, it is important to follow proper safety precautions. Always energize the circuit before attempting any repairs or troubleshooting. Wear appropriate personal protective equipment, including insulated gloves and safety glasses. Avoid working in damp or wet conditions. Have a second person present to assist in case of an emergency. If you are not comfortable working with electricity, contact a qualified electrician to perform the troubleshooting and repairs. Here is more information on ceiling materials. The type of ceiling material can affect the performance of electric radiant ceiling heat. Some materials, such as drywall, are good conductors of heat, while others, such as plaster, are not. When installing electric radiant ceiling heat, it is important to choose a ceiling material that will allow the heat to radiate effectively into the room. It is also important to consider the fire resistance of the ceiling material. Choose a material that is rated for use with electric radiant ceiling heat. Some common ceiling materials that are used with electric radiant ceiling heat include drywall, plaster, and acoustic tiles. Each material has its own advantages and disadvantages. Drywall is a relatively inexpensive and easy to install material that is a good conductor of heat. Plaster is a more durable material that is also a good conductor of heat. Acoustic tiles can help to reduce noise levels in the room, but they may not be as good of a conductor of heat as drywall or plaster. The insulation in the ceiling can also affect the performance of electric radiant ceiling heat. Insulation helps to prevent heat from escaping through the ceiling. When installing electric radiant ceiling heat, it is important to ensure that the ceiling is properly insulated. The amount of insulation that is needed will depend on the climate and the type of ceiling material. In general, it is recommended to use a minimum of R-30 insulation in the ceiling. Remember to always consult with a qualified electrician to determine the best ceiling material and insulation for your specific application. Also remember that safety is paramount when dealing with electrical systems.